All right, here are the recorded answers with my explanations talking you through the homework proofs for 3.2. So we're going to start with 23. So we always start with our given. And we're given that angle BAC is equal to angle DEC, and that BD bisects AE. Now I head over to my picture, and I'm going to mark that angle BAC and that angle DEC, and then take a look at what I have. Now I'm trying to prove triangles congruent, and I see vertical angles because I always see those in the butterfly picture. And I'm given that BD bisects AE. Now the direction of that bisector is important. In this case, AE is what is getting bisected. So what that gives me from the given, I get that AC is equal to EC by definition of bisector. That direction is super important. I know nothing about BD itself. Okay, I only know that AE is bisected. So I have that. So now I have an angle and a side. Of my theorems, I have angle, angle, side, and angle, side, angle. Well, I'm going to look for the other angle or look for either angle B and D or those vertical angles. Those vertical angles are going to come in handy. I can say this angle is equal to that angle. And so I have that angle ACB is equal to, watch the order, ECD by the vertical angle theorem. If you look at my picture, I have enough now, angle, side, angle, and that is how my proof is going to end. Triangle ACB is congruent to triangle DCE by angle, side, angle. Feel free to replay that. I'm going to move on to the next proof. Now number 24 is going to give us a similar set of given, and we have to work with it. Now, here we're given first that C is the midpoint, and we're given that AB is equal to AD. And we're going to go over to our picture, AB and AD. This one also has a typo, and we are going to change our proof to angle BAC is congruent to angle DAC. The way it was, we were done by the isosceles triangle theorem, which is no fun. So AB equals AD, that's given to us. And I'm also given that C is the midpoint of BD. And what that tells me, by definition of midpoint, is that those two are equal. So I'm always going to use my given to write a step somewhere. They don't give you unnecessary information. And those two are equal by definition of midpoint. Now at this point I have a choice. There are two ways to do this. I could say that B and D are equal by the isosceles triangle theorem and conclude the triangles are congruent by angle, side, angle. Or I could use the reflexive side and say the triangles are congruent by side, side, side. I'm going to write it down one way and then I'll do an aside. So I'm going to use the reflexive side because I always want to use that side if I'm given it. It's an easy way. It's something I always want to look at. Right there, they share that side. And so I'm going to write that AC equals AC, because it's fold in half, that's how they'd match up, by reflexive. And if I have that triangle BAC is congruent to triangle DAC by the markings on my picture, side, side, side. And once I have the triangle congruent, then angle BAC is congruent to angle DAE by CPCTC. Now your alternative proof at this point right here, do a little or, I could have done for step 3 that angle B was equal to angle D by the isosceles triangle theorem. Then my triangles are going to be congruent, triangle BAC by triangle DAC by side angle side. And then my same conclusion is that we are congruent in the angle department by CPCTC. Technically speaking, as long as your proofs are the same number of steps, it does not matter which way you do them. Okay, so it's whatever you see when you're working on the proof. Feel free to rewind and replay at that point. I'm going to move on to 25. Now, 25 looks more complicated, but let's start with the given. Never make a determination on how complicated it is until you mark your picture. So I know that OM bisects angle LMN and that angle LOM is equal to angle NOM, and that is all given. LOM, this angle and that angle are equal. Now the fact that OM bisects this angle, make sure you read it the correct way. That tells me that angle LMO is equal to angle NMO by definition of bisector. So now I have these two angles congruent. And the thing that I am always going to look for, reflexive side. It is a fold in half proof. MO is equal to MO by reflexive. I am after this side and this side being congruent. Since my triangles are congruent, I now can say that ML is equal to MN. Whoops, skipped a step. My triangles are now congruent. Triangle LMO is congruent to triangle NMO by angle side angle. And now ML is equal to MN by CPCTC.